The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI Web Sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Thank you. So we're going to jump right in here, and I will hopefully not have any technological issues like I did. So I'm glad that Gene did that presentation, because I did realize the breadth of PT work that restructured that I did know that they had done some. Tony and I had a lot of conversations, and as repair contractors, you know, you always feel an obligation when you're fixing somebody's goof up. You got to do it right, and boy, there's nothing worse than doing one wrong, because then it's even it gets a lot worse quickly. So there's a number of things that could cause damage or deterioration to post-tensioning. Some of the slides I'm going to show today are specific to damage. Some of them are specific to relocating live tendons, particularly in conditions or in cases where you are repurposing a building. So you're cutting through an existing post-tension slab and putting in an atrium, a stairway, some type of mechanical opening. The problem that we have in a lot of parts of the country, and again, our work is in the West, so we don't see the corrosion issues necessarily of the people in the Rockies and East, but we do have those problems. If you look on the far right, that cable in coupler is only 20 years old in a 30-year-old structure. And so someone put this thing in, and it didn't perform very well, and we just took that out at Christmas and replaced it. So there's a number of things that can happen: improper grouting, high concentrations of chemicals, and of course post-stressing errors, a lot of which we see with errant core drillers and post-installed anchors. So corrosion of the post-tensioning anchorage is of huge concern. We've probably, almost all of us or many of us, have seen that. What I can say is the picture on the left, when that was found, that ultimately led to the complete demolition of a 26-story building, that particular condition right there. So that was caused by chlorides to accelerate the grout, which is an absolute no-no. Why it happened in the first place is yet to be, or will never be, determined. And then on the right, a missing grout cap. So through various inspections that we work with engineers, we want to open up and just see what the condition is. Lo and behold, we open up one spot, no grease cap. I mean, you don't know why, but it just isn't there. And then in the same structure, we open it up, take out the grout, and there is the grease cap was there, someone took it off and grouted it. And so it's just odd of what can happen. And on the picture on the right, again, look at, that's severe corrosion. That's just a cable waiting to snap or de-stress any time now. There's no way of predicting it, but that is not a good condition. So this condition here is very interesting. This is a project that we're actually just starting. 6 months ago, the owners of this garage came into work on Monday morning, and on the right there you see a duct laying on the deck. So this is a 1970s vintage parking garage, and not too long after this garage was built, they installed external post-tensioning. Now, personally, I didn't know that there was even any of that done in my part of the world. So this was all new to us. What had happened is on the end, well, you can't see it, on the far right photo, you can see the strand popping out. That was the stressing end. And after some period of time, that area was backfilled and the grade was elevated. So this anchorage was covered and probably never protected. In addition to that, you can see in the center photo that if there was a grout in there, it must have evaporated. So there's a couple things that probably happened. This failure occurred essentially, 40 years after it was probably installed. They don't know the exact time of when it was installed. And what I will say is the condition of this grouting of the duct has led ACI 546 to have a subcommittee to look at the use of prepackaged materials, and that's part of what stimulated it was the poor grouting of post-tensioning ducts. So we have to do a good job of protecting it. Now, how long can you expect something like that to be protected in a buried condition? I don't know what's reasonable. Another thing that happens, and this was through another investigation where they knew they had some post-tensioning problems, was on the photo on the right, wrong, or indifferent, they've got a swimming pool above well, obviously a post-tension slab is supporting the pool, and then where the leakage occurred, which shouldn't maybe happen, was right over the anchorage. Now, in this particular case, it didn't appear to cause any corrosion or damage, but we opened it up, cleaned it, prepared it, and regrouted it. On the far right is another detail of where for 20 years, 10 years, 15 years, whatever the number is, water is draining off of a plaza right over the anchorage. And those are details that could be changed or modified to try to eliminate long-term corrosion or problems at your anchorage. So I don't know exactly at what point, I think it was in the late 2000s, that encapsulated systems were either mandated or extremely common, and certainly before 2000 it was not overly common. There was a building built in Seattle, and they did not mandate encapsulation. They suggested that some kind of protective coating be put on the anchorage. So there's a variety of coatings that can be put on, and if you are looking at structures probably before 2000, you're going to probably find conditions where there is no encapsulation, no protection of the anchorage. And that may or may not be bad, because it really depends on the environment. It depends on the quality of the concrete that is encasing the anchorage. But in these particular cases, we opened this up, prepped everything, and applied a multiple coat protection system. So post-stressing errors, I mean, all sorts of things can happen, and you just never know quite where it's going to show up. The photo on the right, this is very common. We have existing slabs. The cables is very common, or not very common, it's often occurs where the cables have floated to the surface, they weren't properly supported, or maybe they got the concrete a little low, and lo and behold, the cable is right below the surface, and then you put a grinder on it, you're polishing the floor, a little change of use, and boom, there you are, and now what do you do? So we see a lot of this. The photograph in the middle there is, as Tony would say, one of life's little disappointments. Some knucklehead comes in to put in a chain link fence, doesn't even begin to consider that it's a post-tension slab, and he could have hit it more dead center. And so then that leads to an investigation, and then you find more problems because these things have occurred more often. And you know, those things are sometimes simply remedied by the use of a good quality GPR technician or company. On the far right is one of 3 cores that were put through a roof of a low-rise building, re-roofing job, so putting in some new drains, and nobody considered that it was a post-tension structure. And they go in to drill in a 12-inch, or I think that was 12-inch, maybe 14-inch diameter hole through the slab to put in a new drain, and boom, they couldn't have hit it more direct. The only good news is they hit it right at the anchorage. But when those 3 things let loose, because it was all right about the same time, the whole building shook. It was a 3-story building. I mean, it scared the heck out of all of the occupants. Those kinds of problems, although very bad, are more easily remedied because you can get the cable, you're not losing much length in it, and you're still at mid-depth. So grouting, can lead to a problem. After we had this building torn down in Seattle, owners were going crazy and hiring people to come and investigate their post-tension structures in their garages, and they were looking for every little problem, and the reality is that at least we as a firm have never found any significant problems with these investigations. We've done all these investigations under contract with an engineering firm or investigative firm. But oftentimes, the guys that are putting the grout into the stressing pockets are guys that are filling out the rest of their day. They got 2 hours left on the clock, so go mix up some grout and go pack this stuff in. And they may be retempering the grout, they're not mixing it properly. Sure as heck, whatever grout they're using is the absolute cheapest stuff they can find, because it just doesn't matter to most folks. And so you can get some shrinkage and or just poor consolidation. It shouldn't be that difficult to pack a dry pack non-shrink grout in, because just the shape of the stressing pocket and the depth of the stressing pocket. On the far right there is at the ends some beams, and this isn't a great representation, but it was the best photo I had, but it's really amazing to us. We have a job now, it's a 2-year project where we're opening up thousands of pockets to trim the tails. And you'll do 10 pockets and it's literally probably 10,000 PSI grout. It's harder than heck to get out, and you move over 5 more pockets and the stuff crumbles out. There's just no consistency, so if you're trying to bid this, it's really difficult to give a hard number, because you just don't know. If it's 10,000 pound grout and you're trying to carefully excavate that, that's a difficult thing to do without doing additional damage. So in this photos up there now are this structure. This was the investigation that was done about 3 years ago, which led to a large settlement. And now the project is to do a bunch of waterproofing and a lot of other architectural applications, but this is opening up all these pockets, and the tails were not cut to the 3/4 inch length that they should be. Some of them were right at the surface. Some of them were a 1/4 of an inch in, and so you have to go in there and trim all of those, clean them, and then repack them. And this was really interesting. The photo on the right was a part of this investigation, and those little black spots there, some guy was whacking those ends off with a torch, and he must have had his caps right there with him, and that cable was still 500 degrees, and he put it in there and it melted right through the ends of the caps. So we didn't find one of these. We found a bunch of them, and nobody on the team had ever seen this occur. And so the photo on the right is a new cap that's gone in, and it's, again, about proper length of the tail, because if you don't get the tail correctly, the cap is not going to lock in there, or it's not going to seat properly. Now on this project, here's what we're doing to seat the caps. Now, of course, I would find it hard to believe that a general contractor or a stressing contractor who's ever doing the work initially is going to take this kind of care of setting the caps, but this way we're sure that we've got the cap well seated on a properly prepared anchor and a properly prepared cavity stressing pocket. Because we find when these investigations, sometimes they've even used the wrong size cap, and they fall out. And there's never seems to be any huge consistency, at least in most of the structures. Now, in most cases, we've not found serious corrosion. So this is out of an PostTensioning / ICRI document on repair of post-tensioning, which is a great document. I'm a huge advocate of these documents that have lots of photos. They're not long, that a guy in the field could pick up and read and get what he needs out of it. That's the reference down there in the lower left. So these are some of the things that you need to look at if in fact you want to do, or you're doing an investigation, and how critical is it what you found. No tendon repair is needed if there's no significant deterioration or pre-stressing. I mean, that makes perfect sense. If it isn't broke, why fix it? But this is all about going in and sort of investigating and understanding what the problem is. In repair, as in life, we have to understand the problem first before we can remedy the problem. Selective abandonment, I mean, this is the first thing that we say to someone when they call us. Say, as an engineer looked at this, and are these cables even that critical? Do they need to be repaired or replaced? And oftentimes you put the challenge to the design team, and they can find a way to do it, because otherwise these repairs can become very invasive and very expensive. Sometimes if the repair is severe, you've lost the post-tensioning or the pre-stressing, you've lost the cable, then you got to start to really look at what kind of repairs are, and then supplements. You're either going to extract a cable and reintroduce it. You may go in and do a coupling, or in some cases there's going to be some sort of additional external reinforcement, maybe external post-tensioning. And in the case of some structures, as the one that we had in Seattle, they tore the doggone thing down. Right, wrong, or indifferent, that's what they did. The little photo on the right was a real learning experience for me. We were called in quite a few years ago. There's 3 cables sticking out of the end of the building. The grout caps were sitting on the ground. We need to get these fixed. And so we're running around, and of course there's rigid insulation on the underside, and you can't tear it all out. There's all this mechanical, and we go to the other end, and we find these things, and we open up the dead end anchors, and we don't see any distress there. We're trying to figure out what to do, so we finally say, well, we're going to go up and put a stressing ram on it and just see if we can extract it. And then when you pull it out, if it's 40 feet long, then 40 feet in, that's where your break is. Put a stressing ram on it, went right up, it pressured up, in a short period of time, and what had happened was these cables had never been stressed. For whatever reason, in this whole slab edge, these 3 cables hadn't been stressed. They grouted over them. And 10 years later, after the slab continued to shorten, the cables were the same length, and it popped the grout caps out. So there was still plenty of tail there. We could grab onto it. It was no big deal. We were thinking we were going to get a nice little cable replacement or coupling job, and it turned out to be a stressing job. No, there's nothing. I mean, it was just crazy, because everything next to it was fine. The grout was in good shape. There was no distress. There was no distress underneath where we could see. It was just somebody went to sleep at the wheel, including the inspector, if there was one. So you have to know what you're getting yourself into when you're starting to dig into a slab. And I mean, some of the other speakers have spoken to this. As a firm, we do GPR, but it's sort of as a backup. We have in Seattle now probably 10 firms that do it. When we're involved in the job and or if we're asked, we always recommend only one company, and they are by far the best, because everybody else in town is busting cables. And so we just completed a job in Sacramento. It was some external reinforcing, but we had to drill into the post-tension beams, and the local firms there, every one of them told us they couldn't tell us where the cable was. Their level of accuracy was 2 inches. I mean, I could throw a dart and hit it at 2 inches. In Seattle, we have people that can do it within a 1/4 of an inch. Now, do you always cut it down that tight? No, and they can tell you the difference between mild reinforcing and post-tensioning, and a lot of that's just because you can tell the profile of the cable. But these other firms, they refuse to accept that. So you got to know, one, who's doing the work, and for sure you need to have that kind of investigation done, coupled with hopefully pre-placement photographs. We're doing a job right now, and our crew goes out with a set of plans to spot the thing, and embedded in that sheet of plans is the pre-placement photo. That area's been scanned. They can marry it up so they know where to chip, where the anchors are, and then where we can drill in supplemental reinforcing to make the repair. So if you're going to start excavating, and particularly around live cables, you got to do it carefully. You have to be sure that the guys are fully aware of what they're doing, they're properly protected, and you have to always be aware of the bursting zone. You certainly do not want to be excavating on the stressing side of or the stress side of the anchor, and open that up, and then you can lose compression, and you got problems. So we do a lot of this and you have to do this if you're going to go in and capture cables to install supplemental or rescue anchors. So this is the same photo we saw before. This repair was, we took this opening that was already created, we opened it up further, we created the proper geometry, we moved the cables inboard, we put in a new bursting cage, set the anchors, and then placed the concrete. And we have very specific concretes that we use so that we can turn these things over very quickly. We have products that we use that are concrete that we can get 8,000 pounds in a couple of days. We can certainly get 3,000 or 4,000 pounds overnight. So as I mentioned, there's a lot of this work, I'm sure, going on in other parts of the country, but in Seattle, repurposing of buildings and opening up these slabs where you got all kinds of live cables, and you've got to reroute them or terminate them in order to facilitate these openings. And so there's a lot of challenges that come into play. In the one in the upper right, upper left, because when you're de-stressing a number of cables, then you got a bunch of shoring. And sometimes the shoring, depending on the footprint of the building and what elevation you're at, can be a bigger number than the cost of de-stressing. And so we've come up, at times, this is what we will try to engineer in, as we stagger the repairs. So you go to a group, you skip a group, you go to a group, you skip a group, so that you can then get in there and not have all this forest of shores and do your stressing. On the far right, you can see this is right at the corner of a slab. The amount of mild reinforcing that has to go back in after you open these up is sometimes pretty stringent. We found some challenges at times. The last thing you need to do is have so much congestion there that you create another problem in your repair. So the use of couplers, for whatever reason, I'm not even sure why our field guys, we go more to extraction now than we do to coupling, but oftentimes, or not, some of the times, installing couplers is a solution. And of course, you have to allow, if it's out in the field of the repair, you have to allow an avenue for these couplers to travel once you re-stress. Put a coupler in, you pour your repair back, and then you stress it. Not going to work too well. In the document that I referred to earlier, they say you shouldn't use PVC, but the qualifier of using a PVC is depending on the environment. If you're in an environment where PVC won't be attacked, then you're fine. And then it's just an avenue to allow these to slide or to move. So the use of rescue anchors, maybe there's somebody in the room, maybe there's somebody out there who knows it, and boy, I'd love to find out about it, but we only have the ability of capturing one cable at a time. So if you have groups of 2, 3, 5, whatever it is, there's no way of grabbing all those at one time and de-stressing. So typically a temperature tendon is what we can capture, and you put in a temporary anchor. You can then create your new opening, a new anchorage, and re-stress. They're essentially a disposable item that you use. They work very much like a permanent anchor, but they are not considered to be permanent by code. So extraction, this can be challenging. We just did a job, believe it or not, which I actually had words with our folks, because we pulled the 210-foot long cable and reintroduced it. And the reason I had words with them was we were on the hook. If it didn't work, we were in trouble. They assured me they could, and they did it. It took a little bit longer than they thought, but we were successful in doing it. And again, one of the things I mentioned earlier was, as soon as you can extract that cable, you can see where the break is. You can then hopefully find it and go in and do your excavation there and couple it possibly. Or you take the whole thing back out. Sometimes the biggest challenge is on the right there is just breaking the anchor loose to be able to pull it out. But there's going to be a mess. There's a lot of grease. You got this 80-foot, 120-foot long piece of greased up cable. You got to dispose of it. If you're on the exterior of a building in a swing stage, that gets to be a little bit fun. So you can do it by both mechanized or by power operated equipment or by hand operated equipment. So I'm at this point, I'm intimidated because Gene's photos of external post-tensioning were 100 times better than mine, but I mean, this is a cool solution to a project. I worked on a job in San Diego years ago where they put in just a small amount of external PT in precast, and it put the camber back in and solved this problem, and it moved that deck just enough that the cracks closed up and everything was great. We've done a few jobs with it, but not to the magnitude that Gene was showing, but it's a wonderful solution to the right situation. Thank you.